Today, we're going to talk about robotics on the International Space Station. Right now, there are several types of robots in orbit. There's a robotic arm that was used to construct the space station. There's a dexterous robotic space handyman. There's even robots that school children control by writing programs. We'll learn about those and some pretty special robots here on Earth. Join me as we go on board the ISS to learn more about robotics. Hi, I'm NASA astronaut Tracy Dyson. Welcome to StationLIFE.
Houston 2 for velocity calculation, station assembly, steps 45 and 46. We're moving on to step 5.
Go right now for that
Copy,
activity.
thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
In this episode of StationLIFE, we're going to talk about robotics on the International Space Station. We'll hear from astronaut Mike Hopkins and what it takes to control the Canadarm2 robotic arm. We'll take a look at how robotic technologies from the International Space Station are helping lives right here on Earth. We'll have an interview with astronaut Kara Nyberg, one of our most experienced robotic arm operators, and the role robotics plays on the ISS, and hear stories of using Canadarm2 to catch dragons, among other things. So don't go anywhere. We've got a lot of robotic action coming right up.
One of the things that's really interesting with the Canadarm2 on the space station is that it has the ability to inchworm around the space station. It has 7 joints, and that makes it analogous to the human arm, but it also has a symmetric design, which means the base and the tip of the arm are symmetric, and there's an elbow joint in the middle. This means that what starts off as the base can be then maneuvered and released once the tip has grabbed onto another location, and then that base becomes the tip. So imagine my arm as I go from here, as I'm moving the arm here, I can grab on this end and release this end, and I can move around now. This allows me to inchworm around the space station and allow me to increase my range in order to service things and also to do surveys and get the arm around this ISS. Like many people in the world that have a space passion, we all want to become astronauts and go into space. What I realized as I was growing up was that there are other areas that one can perform in the space program, and that was to become a flight controller. Once I became an active flight controller, I remember being in the Mission Control Center and sitting down and about to do an operation which I had written a procedure for. As the operation was beginning, I was looking at the numbers on my console, I was looking at the details of the operation, and I suddenly looked up at the monitor and I saw this beautiful view of the Earth going by. And I saw the Canadarm2 moving across this view, and it just sunk in that this is me. I'm in space. I didn't have to be an astronaut to get into space. I'm a flight controller and part of this beautiful program, and I could see my nation's arm moving, and it just gave me this wave of energy, and I just fell in love with my work. But of course, when that happened, I had to re-lock onto my numbers and focus on the job at hand, but it was a really fantastic moment, and I'll never forget that. My name is Cam Bahrami. I'm a robotics flight controller for the Canadian Space Agency. I'm stationed here at NASA's Johnson Space Center in the Robotics Flight Control Group. My responsibilities here are to support and execute the robotic operations on the space station using Canada's robotic system.
Did you know that we call operating the Canadarm flying the robotic arm? That's because it's a lot like flying an airplane. I mean, it's got hand controls, you can pitch, you can yaw, you can roll, and you have to be pretty precise. Watch astronaut Mike Hopkins describe how we use the Canadarm to catch cargo vehicles arriving at the space station.
Okay, hey everyone. Yesterday we had the opportunity to catch the Orbital 1 Cygnus vehicle, also known as C. Gordon Fullerton. And I'm going to take the opportunity today to talk about the controls that we use for the robotic arm. And so we're actually down in the cupola right now, and this is where we control the robotic arm when we go out and we grapple one of these vehicles like the Cygnus vehicle that we did yesterday. And so this is the control station, and what you see over here on my left, This controls the translation of the robotic arm. And then over here we have rotational control. And then this middle computer is where we actually take the robotic arm into the different modes that we do have. And then on our left over here we have a control panel for the various monitors. So what we're doing when we're grappling is I'm watching on this monitor basically a target on the vehicle, and I've got an overlay on it that allows me to line up the robotic arm with that vehicle, and I just drive right in. Now, I wanted to take advantage today though, because we have a pretty special opportunity here to show you a unique view of the robotic arm. And so if we look out one of the cupola windows here, you can actually see the end effector of the robotic arm. And we don't get a chance to look at this view very often. In fact, today we were doing an inspection on the end effector. And so if you look in the middle, you can see those cables. Those are what we call the snares. And when we go over the pin that's on the vehicle and I pull a trigger, it causes those cables, those snares, to close around that pin. And that's how we grapple onto a vehicle. And actually you can see up above as well, that's the camera that is giving us that view. And that's a pretty unique view for us, and so just wanted to share that with you.
Clearly, the Canadian Space Agency's robotic arms are technological marvels in space. You'll be happy to know that the same technologies are saving lives here on Earth.
1981 marked the debut in space of one of Canada's most iconic symbols, Canadarm. Developed for Canada by McDonald, Detweiler and Associates, formerly Spar Aerospace, the first Canadarm and its descendants, Canadarm2 and Dexter, are in great part responsible for the successful assembly and operating of the International Space Station. Now the technology behind these robots is finding its way back to Earth. By the end of 2014, an estimated 24,400 Canadian women will have been diagnosed with breast cancer. Early detection and treatment make a difference and help save lives. Researchers at the Center for Surgical Invention and Innovation turned to Canadarm technology to develop IGAR. It is a promising platform offering one-stop diagnosis and treatment for patients with a high risk of breast cancer. Currently undergoing clinical trials, IGAR is one of the first robots of its kind designed to work inside an MRI scanner that can show the size and location of tumors more accurately than a mammogram or ultrasound scan. Thanks to its delicate and precise touch, the robot will be able to perform biopsies with pinpoint accuracy, analyze them, and treat early tumors without open surgeries. The platform will also help in detection and treatment of lung, liver, kidney, and prostate cancers, and might also be used for delicate spinal surgeries. Thanks to Canadian Space Robotics, this technology is a step towards a future where surgeons can rely on robots to perform intricate medical procedures that will be less invasive, less painful, and will allow patients to recover faster. Canadian Space Agency, thinking outside of the globe.
My name is Terry Fong. I run the Human Exploration Telerobotics project at NASA, and what we're doing is developing robots to improve the way that humans live and work in space. As humans go further and further into space, as they go to Mars, one of the big things that we're going to need are robots to help humans live and work when they're very, very far away from Earth. You know, if you think about being on Mars, one of the big challenges is how do you carry out work on a surface? How do you work outside of a habitat? And so one of the things we're trying to do is create robots that can work ahead of humans, robots that can work in support of humans, and robots to follow up, doing those things that humans need robots to do to finish up work. I'm just really excited about the idea of humans and robots working together. Well, frankly, that's the future.
Well, guess who we have with us today? We have with us none other than one of our most experienced robotic operators and leaders in the astronaut corps in that category, Dr. Astronaut Karen Nyberg. Welcome to StationLIFE.
Thank you very much.
I don't get enough of Karen. We actually sit right next to each other. Our office desks are right next to each other. But she is someone that I greatly admire for all of the experience that she brings to the International Space Station. She has been part of the construction work on STS-124.
That's correct.
She helped to bring a module, I'll let her talk about that in a second, and attached it to the space station. And then she lived on board the space station during Expedition 36 and 37 and did a number of tasks with the robotic arm at that point. And so there has been rarely anyone else that has touched that robotic arm control than Karen Nyberg. So please, Karen, tell us a little bit more about the experience that you've had operating robotic arms on board the space station.
I've been very lucky. I've gotten to do pretty much everything that it was designed to do with it. As you mentioned, STS-124, we brought up the Japanese laboratory in the payload bay of Space Shuttle Discovery, and we used the Canadarm to take it out of the payload bay, move it around, attach it to space station. So that is one of the big tasks that the arm was designed to do originally, is carry heavy or big masses. And
And Kibo was one of the, or we call Kibo's the whole complex, but
Right.
the pressurized module is the largest, is it not?
It is. It is.
And talk about, because didn't you also on your shuttle flight operate the PDRS, the shuttle arm?
I did.
Okay. Talk a little bit about, because this is exciting, the difference between that arm and the station arm in terms of the joints.
Right. Well, the shuttle arm was pretty much fixed at the shoulder where you could have some pitch and yaw. The station arm also has roll at the shoulder, which adds another degree of freedom, so you have a lot more motion with the arm. And also you can move the location of the station arm.
Yes.
On station. So you could go along the truss and move it to different
Yeah.
places and move it to the lab. And they do this little inchworm maneuver, they call it, where they attach one side, release the other, and inch it along the station to different spots.
That's creepy, but also kind of exciting at the same time. And so you did this motion, which, what do we call this one? The pitch plane?
Pitch plane, yeah.
We can only do that with the station arm.
Right.
And that's also what kind of makes it exciting, versatile, and dangerous at the same time, right? Because you can be moving, like this part of the arm can stay still, and this part can be moving around.
Right.
And there's just a ton of stuff you got to be looking out for when you, I mean, your mind is going constantly as you're operating that robotic arm. So talk a little bit about your space station experience. I know we had a number of cargo ships come up, and they all require at this point a grappling of the arm and an operator at the other end. Which vehicles did you grapple?
We had HTV-4 arrive.
Again, Japanese do big things big. That's our biggest cargo ship.
Yeah. So I was at the controls to capture that, and we also had orbital demo arrive. So it was the first orbital sciences vehicle. Luca captured that, and I was working with him during that. And I have to say, of all the things I've done in my spaceflight career, when I was at the controls of the arm, and it was just the realization that that vehicle's coming in. There are thousands of people around the world who are counting on nobody but you at that time to successfully capture that vehicle. And I didn't think about it much as I was doing the flying, but as soon as I finished and we confirmed that we had it captured, I could tell my heart was about to come out of my chest. And it just really shows, I mean, a lot of the things you do, you're working more as a team, and you're always working as a team, but for that moment when you're at the controls of that robotic arm, it was me or nobody.
It's all
at that point.
And that's pretty cool. I mean, you can focus through that heart pounding, and you're probably like pushing that aside. I have no idea what that is, but when it's over, the flush of wow, I just did that is pretty rewarding.
Yes, absolutely.
So I would say, so you've operated 4 different arms. We include the OPSS. You have grappled 2 cargo ships. You have grappled a robotic arm, the largest element, pressurized element on the space station. Karen, with all of this experience, and you've worked with so many different other individuals, other astronauts coordinating these tasks. What would you say was the most rewarding part about your robotics experience, both in space and in training for it?
I think it's the most rewarding thing in all of these robotics activities is similar to the most rewarding thing in everything we're doing when we're traveling in space, is getting the job done and getting a job done well, and working as the team to do that. You know, during the spacewalks, we wouldn't have been able to do the spacewalk activity without the robotic arm help, so I was an important part of the team. Capturing a vehicle, we could not capture the vehicle without the robotic arm, so a very important part of the team.
Well, I'd say that there's very little of the space station that would exist today if it were not for the robotic arms, and especially that big Canadarm2 that we have used to move so many elements of the space station. So I just want to thank you so much for coming on the show today, Karen, because this whole episode is about robotics, and when I heard that that's what our topic was, the first person I thought of was Karen Nyberg. So thank you for being here, and it's been a real pleasure, and we hope to have you back.
Thanks for having me, Tracy.
Welcome. The Canadarm and Japanese robotic arms aren't the only robots we have on the space station. Meet Robonaut. It not only looks like a human, but it's also designed to work like one too. With hands and arms, Robonaut is able to use the same tools that astronauts use. In the future, Robonaut may be used to perform hazardous maintenance tasks or even spacewalks.
Robonaut, a robot meant to work with humans and use human tools. R2's head houses not its brain, but its vision equipment. Behind R2's visor are 4 visible light cameras, 2 to provide stereo vision for the robot and its operators, and 2 auxiliary cameras. A 5th infrared camera is housed in the mouth area for depth perception. Each arm boasts 7 degrees of freedom and the strength to hold 20 pounds in any pose in Earth's gravity. Each arm is approximately 2 feet, 8 inches long, giving R2 a total wingspan of 8 feet. Instead of feet, the robot has clamps that allow it to latch onto and climb up on objects. The legs are also longer than human legs, a span of 9 feet, 2.7 meters, and are more flexible, giving the robot more ways to cling to things inside or outside the station. The advantage of a humanoid design is that Robonaut can take over simple, repetitive, or especially dangerous tasks on places such as the International Space Station. Our experience with R2 on the station will help them understand its capabilities for possible deep space missions.
Welcome back, and thanks for watching this episode of Station Life. Today, we learned about robots. We wouldn't have been able to build our International Space Station without the Canadarm. Good thing for us, spin-offs developed from the technology are helping patients with neurosurgery, and it's now being developed to help those with breast cancer. We're also developing new technologies for robotics in space and on Earth. If we're to succeed with future missions to Mars, we need humans and robots working together. And that's a wrap for this episode of Station Life. So be sure to stay in touch and follow us on Facebook and Twitter for the latest research news. And don't forget to download our kickin' new app for your mobile device. Until next time, stay with us. Off the Earth, for the Earth.